Alright, so before I get into what my code does, let me provide some background. So the situation is there's a water recharge facility, which is this, and then we're supposed to analyze the flow of the water and the heat. So my code is supposed to be able to analyze that. So before I run it, let me explain the inputs since there is a lot of them. So we have an H top, which is the top heads, and we have bottom heads. These are constant, which the user is supposed to provide. And then we have the change in distance dx, which is the distance between the nodes that we're analyzing. And then we have the hydraulic conductivity, the porosity, the dispersion, the heat dispersion coefficient, the change in time in hours. So this is like half an hour. And then we have the last time, or like the ending time. Like we want to analyze this for like 7 days, it has here. And then we have the average temperature, the amplitude of temperature, and then we have the bottom temperature constant. And then here are the node coordinates. We have node 1 x and y and node 2 x and y. So if you're wondering what this button is, it's just a side note like on the dx, because when it gets to around a dx of 5 or lower, then the times start getting pretty long. I got this information from using TikTok in the code, the TikTok function. Alright, so let's run it. So this first plot is the surface heads, and this is found by using a cross, which is like the average between the points around the node we want to analyze. So if we want to analyze this node right here, then we do the average of the top, left, right, and bottom. If we're on an edge, then we do the average of the top, then we do 2 times the, like if there's no node right there, then we do 2 times the opposite, kind of like there's a fake node there. So it'd be the average of top 2 times the right and the bottom. When we get to the corners, it's the average between the 2 nodes that are there if we want to analyze this. So like there's 2 fake nodes. So we do, or actually we just do the average, just the average of these 2. So for the next graph, the velocity, this is the flow of the water, or the velocity of the water, and this is found by this equation over here, and we have the flow divided by the porosity. So it could also be written as the hydraulic conductivity, like minus hydraulic conductivity times the difference in the heads over dx. And we only need, for both vx and vy, we only need the dx, because dx is the same as dy. And for this change in age, we're doing finite difference, which for let's say vx, if we want to find this node right here, then we go to the surface heads, and then we do standard difference, because we take the forward and the back, the difference between the forward and the back. And then if we're on a corner or on an edge, then and we want to analyze like this velocity right there, then we take the backward distance. No, it's the forward difference, because we take the forward and the node itself. So the other side is the opposite. We take backward, because we take the difference between the node itself and the node previous to it. So it's like going back. And then that's how this is found. Same thing in Vy. So this plot is the temperature in all nodes, and this is found similar to the surface heads, but the main difference is the top row is changing with time with this equation, the average temperature plus temperature amplitude times sine of 2 pi time. And the bottom row is the user provided constant. And if we look at the coordinates, the 75, 20, so that's like 75 over and 20 down, so about right there. That's like in between green and this greenish blue, which is about like around 52. So we look over to this graph, which this plot, the temperature in all nodes, is supposed to represent the last point in time. And for this, at the 52 temperature, it's about right there for the last point in time, which right now we're looking at the red dots. And for the second coordinate, 75 over and 40 down, which is about right there, like greenish blue, just a tiny bit lower, which is right there about where they cross. And you could see the temperature changing if I change the nodes. Like if I make the second coordinate a little bit down, like let's say 60, then it kind of goes lower, because it's supposed to get colder as it goes deeper into the ground. And then we could look at maybe say 80. See, it gets colder, the second coordinate gets colder. And that's pretty much my project.